Okay. Welcome to the Nature Podcast, where we explore the wonders of the natural world and uncover the science behind the environments that shape our lives. I am Ankit Sengupta, an architect, and currently I'm working as a research assistant at South Asian Institute for Advanced Research and Development. In today's episode, we'll dive deep into geology, climate resilience, and the majestic Himalayas with one of the India's foremost expert in the field. My guest today is Professor Mahesh G. Thakkar, who currently serves as the director of both the Birbal Sahni Institute of Palaeosciences and the Wadia Institute of Himalayan Geology. Professor Thakkar is a leading authority on Earth's dynamic processes with decades of groundbreaking research in the regions like Kutch and the Himalayas, some of the most geologically significant areas on the planet. In this episode, we'll explore the stories buried deep within the Earth's crust, from the fossil records of ancient life to the resilience of mountains that have weathered millennia of change. Professor Thakkar will guide us through the journey, offering insights into how the Earth's most powerful forces shape our world, and more importantly, how we can learn from these natural systems to face modern challenges like climate change and the adaptation of Himalayan settlements. We'll also touch on the fascinating geological complexities of towns like Joshimath, which sit on the edge of geological change, and how studying these areas provides practical insights for sustainable development and resilience. Whether you are a geologist, a nature enthusiast, or someone who's simply curious about our planet works, today's conversation is filled with science based knowledge and practical insights into the world around us. Stay tuned for a deep yet engaging conversation on unlocking the secrets of our nature. Welcome, Professor Thakkar.
Thank you.
So, sir, as we were searching about you and we were researching about you, we got to know that Kutch seems to be a place that holds a special connection for you. You have dedicated a major part of your life studying this unique region. What first sparked your interest in Kutch? What was the reason behind?
Uh, Ankit, first of all, I would be very much grateful to all of you and your NGO for inviting me to this particular podcast forum. The As you asked me about my agenda of working in Gujarat, and that too in the far western part of Gujarat, that is the run of Kutch and the Kutch Basin. Basically, after the master's degree, I since I am in Gujarat, I hail from MS University of Baroda.
Right.
The geology of the Kutch region, actually fascinated geological formations. It fascinated everybody, those who are coming from all corners of India
Right.
and from all over the world. They are fascinated by the geology of Kutch. Why? Because it is a very small basin, maybe around 300 kilometer long and almost 250 kilometer wide. It is in a very small basin. We have got the Jurassic rocks, Cretaceous rocks, and Cenozoic sequences. And the Jurassic rocks are basically the marine systems, and Cretaceous are the system which is the deltaic formations of the large river systems of the Cretaceous time. That means around 140 million years to 65 million years of period. And the rest of the Cenozoic, they are the marine transgressive regressive formations. So that is one of the best place to study the sequence stratigraphy. So that particular idea that actually fascinated all of us, and especially me, when I intended to work in the quaternary period. So quaternary period is very small period in the entire geological time scale. If you think the
Okay.
geological time scale, the overall age of the Earth is a 4.5 billion years. That means 4,500 million years. Out of them,
Right.
only uppermost 2.6 million years is the quaternary period. So my interest
Okay.
was the quaternary period. So
Okay.
as the quaternary is an almost in those periods where I started studying in 1990 and 91, the quaternary study was very unique or new. Very few
Okay.
people were working all over India regarding the quaternaries. Of course, the
Right.
Himalayan quaternaries was very much famous in some of the aspects, and
Mm,
the quaternaries of the Gujarat alluvial plains, that means Narmada
mm,
rivers, Mahi River, Sabarmati River, they actually made huge quaternary formations in the Gujarat alluvial plain. So that was very interesting, and that fascinated me, that why the similar kind of work of the last few million years, or 2.6 million years, and that to the late quaternary period, that is just last 1 lakh year, that means 100,000 years. So that
right.
kind of study can be carried out in Kutch. So
Okay.
so then we, especially me and my guide, we started searching about the for the deposits which are very interesting. So after that, we could see that vast Great Run of Kutch is basically the formation of last few thousand years, which we
Okay.
today the people are going there just to see the beauty of the Great Run of Kutch. As people
Right.
said that Kutch nahi dekha to kuch nahi dekha. It is a
Mm,
vast white salty encrustations. But
exactly.
that basically encompasses the huge deposits, maybe around 100 to 400 meters of quaternary deposits. So that
Okay.
gives you the idea of last few thousand years of the geological and climatic history. So that
Okay.
basically inspired me to work in the Kutch quaternary formations.
Okay. So, sir, as you were mentioning about this quaternary and the last quaternary of the period that you focused on, sir, did you come across any such ancient ecosystems that existed in Kutch, which was very much different than what we see today? Was it like that, or was it very different to what we have now?
See, when we go back in, as far as the Kutch is concerned, when we go back by a few thousand years, if you are well aware about the civilizations, our civilizations, which is around the Indus River and Vedic Saraswati River, that is called Saraswati Sindhu Saraswati civilization. So there are some around 150 plus archaeological sites of the Harappan civilization, which we call now is a Sindhu Saraswati civilization. So if you
Right.
go back by just 5,000 or 6,000 years of the history, we have almost altogether different type of the climatic system which we can find out in which was existing in terms of the coastal climatic systems and the hinterland climatic system. But even if we go back by a few thousand years, say for example 40,000, 50,000, then there are some evidences which we found from the Kutch geology, quaternary geology, that some different environment was existing. But
Okay.
if you see these 5,000 years, the environment was little bit of arid, but there were some phases which we could find out in the sediments, that shows the very warm period, and that warm period is now repeating. Now
Right.
today, in last few decades, that warm period is repeating, and we are getting very huge rainfall. So that is what we now say that climate change, and that climate
Climate
change
change.
has actually it proved boon to the Western India.
Exactly. So, as we can see that climate change is very evident, and like it is somehow related to urbanization as well. So, in Kutch, how do you define climate resilience when we see that urbanization is at its peak, and like only through urbanization, every country it measures its development. So in such case, how do you think that the run of Kutch, how should the government or the policymakers should see run of Kutch as, like, how can they deal with climate change in such situation? Like,
If you are well aware about the today's development in the Great Run of Kutch, see, because I have seen from 1991 onwards till
right,
today, 2024, different phases of the Great Run of Kutch. In between, if you remember, there was a big tectonic event that took place in
right,
the Kutch Basin, 2001
Bhuj,
Bhuj
Bhuj,
earthquake, or say it is a Republic Day earthquake. So
exactly.
basically, that is a tectonic effects. That means the earthquake internal energy that actually made this big hazard or disaster in Kutch. And in terms of the climate is also playing major role in shaping the landscape. Okay, that is a very general idea. But if you see today's development, earlier, if you see 1990, there was no road system, there was no border road. Our BSF people and army people, they used to have very tough time early
Mm,
days. That I have seen. Okay, there was no border road, and it was kind of porous border during 90s,
right.
90s, and even after the 2001 earthquake. But
Mm,
after 2001 earthquake, almost around 2005, the then I mean the government has started working on the border road systems. So
okay.
making the border roads, now the system is very much changed. If you see today, now I jump to 20 years. If you see that today's Great Run of Kutch is almost the beauty of the Great Run of Kutch is now vanished. If you
Mm,
zoom in the Google, and you will see that the Great Run is now covered with the solar panels and
mm,
windmills, big wind farms, and
right.
not in one or two. It is in thousands. Okay,
Mm,
and the solar panels are in lakhs of solar panels. So that
mm,
is one way we are the Gujarat and Kutch becomes the energy hub.
mm,
At the same time, your beauty of the run
mm,
and the actual geological treasure, which actually the climatic and tectonic past, which is preserved in the Great Run of Kutch, is now lost. But at the
exactly.
at the cost of ecology also, there is a separate ecology of the Great Run of Kutch, which is now
Mm,
lost. Now, if you see and move to this area, you will see the solar panels, salt pans. There are hundreds and hundreds of salt pans. They are making the brines out of the groundwater which is found in the Great Run of Kutch. So the phases are now changed. And as you said, urbanization. In the
mm,
Great Run of Kutch, there is no urbanization. It is called the
mm,
industrialization.
right.
Urbanization is there in Bhuj, the towns where you get the I can
Settlements are there.
settlement. The urban areas are Bhuj, Gandhidham, and
Mm,
Mandvi, Nakatrana. These are four regions. Bachau is also coming up with the industrial development. But
okay.
as far as the Great Run is concerned, we have total industrialization. That is that too the solar power and wind power. Nowadays, after getting the green energy, that means solar energy, we are
Mm,
now getting the green hydrogen also. You know,
right.
hydrogen, in which when you produce hydrogen,
Mm,
you don't have to spend the electricity or any other conventional fuel system. So if you are
okay.
using the wind and solar energy producing the hydrogen, then it's called green hydrogen. So such kind of plants are now sprawling up in entire Greater of Kutch. So it is
Okay.
all three together. So that is called the hybrid power projects, all
Mm,
three together. And there are many
okay.
companies, big giants are there in Greater of Kutch. So
Mm,
if you see, The beauty, the Kach nahi dekha to kuch nahi dekha, is now lost. You won't
Mm.
see anything because the total area would be 1,000 square kilometer where these all solar panels and wind farms are spreaded.
Right. Is there a solution to that? Do you think, like, as we know that for solar energy farming, it is very important to have solar panels. So, is there any technology coming up which is minimizing the size of solar panels, maybe, or to some extent, so that the aesthetics of the part and the visual value of cuts, it is not lost? Do you think anything could be done in that
So that
case?
is that is not actually my cup of tea, to be very
Okay,
frank, because this is a technology
right.
uh, part of the panel system, and the I think the time will come that the solar panel which we have huge one with the aluminum
Mm,
sheet and the solar
mm,
the silicon sheet, everything, this will be reduced definitely with the
mm.
time. uh, there is no
Science, yeah.
question about it, but it is the matter of the technology. And
Mm,
but then this entire system you have to put into the junkyard, so that will be another big issue.
mm.
Like
Big
what
issue.
happens in the battery system, now we have a recycling of the battery, that is a big
Mm,
issue. Throwing out all batteries from vehicular, all XYZ battery systems from the
yeah,
electrical vehicles, EV
the
vehicles.
disposal of it.
Now
Yeah,
this is a big issue
issue.
for India and
Right.
all over the all other countries.
Mm,
Yeah.
it is. Sir, you are the director of Birbal Sahni Institute of Palaeosciences. Sir, would you like to explain to our viewers what is paleoscience and how can it contribute to climate resilience?
Paleo means past.
Right.
Paleo means past. One which
Mm,
is few hundred, few tens of years, few hundred years, few thousand years, or millions and millions of years. That is called paleo. And science means science. Okay.
right.
So our institute, basically, our institute earlier was known as Birbal Sahni Institute of Paleobotany.
Okay.
Only from 2015, the
Uh,
name and is changed because our perspectives of our scientists, it is changed. So
okay.
if I go back by maybe taking 2 to 3 minutes,
Uh,
the institute was established in 1946, just
right.
before the independence, by
Independent.
the Professor Birbal Sahni. Okay, he actually studied in Cambridge, and then
Okay.
after studying the botany and the paleobotany, he came to Lucknow, and he
Okay.
established the Department of Geology in Lucknow University. But before that, he worked in Banaras Hindu University in the Department of Botany. He also established the Department of Botany in Banaras Hindu University, and
Mm,
he worked in the botany department in Lucknow University. Okay.
mm,
And he established this institute in 1946. But just after the foundation stone, he laid the foundation stone. After 7 days of that foundation day, he passed away because of the heart attack. And then entire task of for establishing the institute,
mm.
the science of the institute, the construction work of the institute, the vision, everything carried out by his wife, Savitri Sahni. So,
Okay.
but the idea, vision, the
Mm,
objectives, they remain the same. What was the idea? Because when he came and he studied in India about the Gondwana plant fossils.
mm,
Gondwana is a word, I think
mm,
many of you may not understand what is the Gondwana period. Gondwana
mm.
period is, I think, 320 millions, 340 millions to 65 million years period, which we call the Gondwana period in
Okay.
the Indian subcontinent, and the Gondwana land of several other continents together, like Australia, Antarctica, India, South Africa, and South America. These all continents together known as the Gondwana land. Okay,
Hmm.
and it's split apart in some point of time in the history, 260 million years ago. But during those period, 260 to 320 million years of period, there was huge uh, forest cover in entire today's Bihar, Madhya Pradesh, Orissa, Jharkhand. These are the regions where the big trees were there, huge trees, and they grew, they bury, they grew, they bury. So there
Oh,
are cycles of the growth and burial, and
right.
that gave us the coal.
Fossil
Coal is
fuels.
the fossil fuel. Coal is the koila. In Hindi we
Hmm.
call. Okay, so that coal formed due to the burial of the big huge biomass. So that
Hmm.
biomass or buried biomass ultimately become the fossils. So these fossils have been studied by the by Professor Birbal Sahni, which is called the Gondwana plant fossils. That time those
Okay.
plants fossils were huge. Their tree trunks were very huge, and their leaves are very huge. It is called the glossopteris and many other plants, Williamsonia, Nilsonia. There are plant
Right.
names are many, but the very first idea was this Gondwana plant fossil. So the institute actually formed on Gondwana study of the Gondwana plant fossils. Later on, when scientists joined in this institute, and they studied vertically and both the way, down and up. So it
Okay.
means in the geological time scale, now we have the scientists, those who are studying the 3.5 to 3.8 billion years. That means 3,700 million years of fossils till today. So we have a
Okay.
large time span where the scientists are working from the Precambrian era,
Hmm.
Proterozoic era, then Paleozoic era, Mesozoic era, and the Cenozoic era. So uh, the verticality, the scientists are working, and there are groups, those who are working in different aspects. Now, in terms of the fossils, the fossil flora and fossil fauna is also added. For fauna in the sense the animal fossils. So we
Hmm.
have the fish fossils, the scientists working in the on vertebrates, invertebrates, the Prushtavanshi prani, Aprushtavanshi prani. So these different kind of animals are also now in the list of the scientists. Microfossils, nanofossils to the megafossils. So these are
Okay.
the vast spectrum the scientists have now covered in terms of the vertical development and horizontal also in all over all states of India. Our scientists are working from the coastal
Okay.
region to the Himalayan region, east to
Hmm.
west, from the Great Run of Kutch to the ocean, from the
Ocean.
Pacific Ocean core, Atlantic Oceans core. Our scientists are working.
Okay.
Their jurisdictions are the Antarctica and Arctic.
Hmm.
So we are working in a very vast regions. Our scientists are working, and that is why there is a need that the entire the institute should be known as the Paleoscience. So they are
Hmm.
not restricted to the only paleobotany. We
Hmm.
have a vast system, so it is a Paleoscience. Okay.
Okay. So, how is BSIP's work contributing to climate resilience, in your opinion? And how have you been working as a geologist yourself? How has been the experiences been contributing to climate resilience?
So when my scientists are working in a different domains in vertically in different time periods. So
Right.
when climate change, we want to study the climate change. If I say to the common people that I am working on 100 million years old climatic systems, so they will laugh at me. You,
Right.
if you are a common man, you will laugh at me. what actually affecting us, that if you talk about the 100 million years old climatic system, okay, that is very true. So if my window, study window, is very small, say for example, last uh, few 100,000, 1, 2, 3, or 5 lakh year, when human came, the present day Cro-Magnon or the Neanderthal man, when they came to this earth and they actually started evolving the way now we are. Okay, so if I say about the 500,000 years of climate, or 100,000 years, or maybe 20,000 years of climate, then you will understand that yes, this is reasonable. Okay, so my scientists are working in a very small window also. So those
Okay.
working in a small window, they are the late quaternary geologists. So in
Okay.
that case, if I want to extrapolate this knowledge to the next few thousand years or few hundred years from today, that means future, then I have to find out the cycles, climatic
Hmm.
cycle. So these climatic cycles, whether it is a warm climate, arid climate, humid climate, or kind of a glacial period. So if
Hmm.
I get this cycle and you understand the cycle through the through the sediment study, then I will come to know about the next few hundred years or few thousand years or a few tens of years what will be the climate. And that is
Hmm.
what the data which we, our scientists, are gathering. So what are those data? The geochemistry,
Hmm.
okay, data of the geochemistry of the sediments, data of the pollens and pore studies, that means
Right.
uh, the palynological studies, data of the microfossil studies, okay, of last few thousand years, and there are many other aspects. Those data will be carried out, and the not only India, but this data will be plotted in the world map, and then you come to some conclusion that what is actually happening in all these periods, and what is now future next 100 years
Going
of
to.
what is going to. So this is what the contribution is, and some of our
Okay.
scientists are in a larger group, you know,
Hmm.
ipcc group. There are 2000 scientists in the world in the ipcc group, and some
Okay.
80 countries are involved in the ipcc. So out of them, one or two scientists are actually attached with this group. So
Hmm.
these database is a very crucial database. Based on the IPCC report, now we have several sustainable goals.
Hmm.
UNESCO has also given the
Yes.
sustainable goals based on the, because it says that in 2100 what will be the sea level,
Hmm.
and in 2030, 2075, because there is a software through which all this data, when you plot and you put into the software, and you get the simulation key, next 10 years, 20 years, what will be the sea level, and what will be the future of the coastal region of the world. So
Right.
in that case, Mumbai, Kolkata,
Hmm.
Chennai, many other ports, even in Kutch also, Kandla, they will be under the water in next 25 years. If this climate continues and we are not taking any measures
Measures.
in terms of the
Hmm.
wherever the humans are involved, then we
Hmm.
have to be very sure about. And when
Hmm.
humans are not involved, but purely natural systems, Milankovitch cycles, wobbling of
Hmm.
the earth axis, if that is we cannot avoid,
Control.
it is
Yeah.
going to happen. But we
Exactly.
need to take the measures of those
Hmm.
effects also.
I think that's really insightful, like studying the past and then predicting the future. So that is kind of giving us a holistic approach and a holistic view of what is going to happen. Like
That's
we can only say that, like studying about our past. So yeah, that was really insightful, sir. Um, Sir, as you were mentioning about the Gondwana land, uh, we also saw like we know that when the Gondwana land it came towards this subcontinent, it gave rise to the Himalayas, and the Himalayas hence started forming since then. So, sir, how did you transition from specializing in an area like Kutch to Himalayas? Like, how did the transition happen? And can you please highlight
This is a
that?
very long story. In
Okay,
fact, I would say that my mobile, from where I am taking the hotspot, is now running out. I'll just
okay,
fast forward it. Okay.
okay, okay.
Uh, so according to your the idea what you describe about the Himalayan system and Gondwana system, but it is not Gondwana, the Indian plate, which
Mm,
basically drifted to
mm,
the and they collided with the Eurasian plate, and in between there was a big ocean which is called Tethys oceans that uplifted the all sediments has uplifted, and because of
mm,
this Himalaya is rising, and
mm.
the way it has been it has attained that height
Hi.
almost around 8.5 kilometer or 8.9
Mm,
kilometer. So this is
right.
very unique system in the world, and the youngest mountain chain in the world. In that case, Gondwana has nothing to do. Gondwana system has nothing to do. Okay, because it's very
Okay,
old. It is just 45 million years. Himalaya rising
okay,
is 45 million. Kutch is also rising in the 55 million years from
right.
last 55 million years. But it
That's
is
right.
not orogenic zone. The Himalaya is orogenic zone, and that is why it is rising very fast. So orogenic mountains are always like that. But the unique thing, I'm a little bit fast, okay, because now it is
Okay,
running
okay.
out. So
Totally, sir.
the unique thing is where the Indian part of the Himalaya is, which is very steep. Okay, I'm
Mm,
coming directly to the point. It is very steep, almost 45-degree of the slope. And the other part, that is a trans-Himalayan region, which we call
mm.
the Tibetan Himalaya,
Hit
which is
plateau. Yeah.
almost flat, which is a flat. So
Mm,
development in the Tibetan part is very simple.
mm,
They can move everything machineries, but in Indian Himalaya, which is always steep. Okay, so there is very crucial. So anything which is developed on the slope of
mm,
45-degree or maybe more somewhere,
mm,
it is very dangerous. So we have to
mm.
be very
Cautious.
cautious about development in the Himalayan systems, Indian Himalayan system rather. Okay,
Mm,
so as far as the Joshi Mutt tragedy is concerned, okay, that is very important part, and it is alarming bell. I tell you, it is
right.
alarming bell. What actually human, the anthropological activity is actually instigating or the entire system. The natural system
Exactly.
is the slope. Okay, we have to understand the slope. But
Mm,
now we are instilling many things, because when you understand the entire system, what is that system? Because it is made up of the glacial till deposits, which is
mm.
very loose material, over which
Those.
now we have the town, and this town has the drainage system we call the gray water. That gray
Mm,
water has to stop in the crevices. This gray water instills, and it makes the entire system unstable, and that actually governs the crack and landslide systems.
mm,
So we have the gray water, then groundwater, then deforestations of the
mm,
entire area.
mm.
That is actually the human input. We have to stop
Mm.
that immediately.
Exactly.
Because this is alarming. Well, there are many other areas where similar Josimat can happen. I tell you.
Right.
Yeah. Natural system is there. We have to understand the natural system. It is slow. We are
Mm.
developing the slope. So whatever the criteria we have to follow, it should be very stringent criteria, geological as well as the civil engineering based criteria that we have to follow. If we are not following, we are going to have another several Josimat.
Exactly. In fact, the population of Joshimath it has been rising severely these days due to tourism and such things because people are developing hotels due to such reasons. And that is the reason it is totally going out of our hands. So I think it's a really important alarming bell, as you mentioned, that we take care of this place so that not more than Joshimath, nothing else happens, something like
The
that. I think
population
it's
is
really
growing very
important.
fast, and it is actually need. The population,
Exactly.
where this population will go, that's the big issue. and
Exactly.
and we have to develop something. And
Exactly.
but the social, the infrastructural, all loads will be there on these mountains. So we have to learn the mountain, we have to learn the characteristic of the rock systems, and then we have to develop the any growth which we actually pursue in these systems.
Exactly.
My things are going very, very fast. We have very few minutes now. Okay.
Okay. Sir, just last couple of questions. So the question was, do you think local communities can contribute to Himalayan resilience in Joshimath? Like, what could be their contribution in that?
See, local community was there since long. So, see, you go back by 1,000 years, 2,000 years, 5,000 years. They were very, very sustainably. They are growing there. They were growing there. They knew the system. They
Exactly.
knew the entire system ki what is actually how vulnerable the Himalaya is, how sensitive the Himalaya is, how fragile the system is. But when the last couple of centuries after the industrialization, these entire things are now came into the picture, and because of the increasing the populations, because the population increase, we need more and more farms. So we cut the
Exactly.
forest and make the terrace farming, and that is a vulnerable thing. In the
Mm,
hilly area, when you cut the trees and make the terrace farming, that will lose the soil property, and that
mm,
soil erosion is tremendous. And that see the rainfall, which which actually percolates the water inside and make entire system very fragile,
fragile.
lubricant. Okay, so these are the
Mm,
things we have to understand, and at the same time, climate change is a big issue. And
mm,
flash flood system, the cloudburst system is a frequent because of the global temperature is rising. Sea surface
mm,
temperature of the Arabian Sea is rising, and that actually
mm,
creates the cyclones and
mm,
vulnerability in the climatic systems. So
mm,
that everything is combined, and
mm,
the fragile system is now becoming more and more fragile.
mm. Yeah, along with the, as you mentioned, the along with controlling the development of the area, what is also important is the construction techniques that the people are following there. Like they used to follow construction techniques like Katkuni architecture and Koti
Mhm.
Banal architecture style, but they are not following that now. They are using cement brick mortar, which is definitely
See,
not sustainable.
Ankit ji, if you change the techniques, they need money. Where is the
Exactly.
money? Okay, they
Mm.
will go for the very, very
Cheap material.
simpler way. But
Mm.
if they use the very, very simpler way or traditional way, the 100 years or 200 years back or 500 years back, the people used to use. That is the most important thing. They should use those traditional
Methods.
materials, not the
Yeah,
cement and concrete and other things.
exactly.
They use the old techniques, then it is
Mm.
good. They have to, but nowadays, in the rapid growth, you need all these aspects. As there are
Exactly.
100 examples in other parts of India, where,
Mm.
like in 2001 Bhuj earthquake, the
Mm.
Banni bungas, the kind of hutments, not a
Mm.
single bunga collapsed, but most of the
Exactly.
other houses are collapsed. No bunga,
Exactly.
the small
Mm.
round hutments. So
Yeah.
these are many things, but in the short
Mm.
period, I have to be very fast about
Mm.
speaking also.
Exactly.
Sorry for
So,
that, my
yes, sir.
constraint in the battery system. Okay.
Oh, so the last question.
Yeah.
How do you think Wadia Institute of Himalayan Geology it is contributing to resilience of Joshimath? How are the things Wadia Institute is doing?
My scientists are working on this Josimet and other issues because my scientists are in a different background, like geophysics, then
Okay.
climatic hazards, tectonic hazard systems, the Himalayan dynamics, and related to all aspects of Himalaya, though it is a ecology, climate. So scientists are working in the domains of most of the Himalayan aspects. So recently we have got one project on Joshimath after Joshimath tragedy, but the kind of instruments which we are going to implant is still take it will take time, but
Okay.
the government is sanctioning many projects to us
Okay.
for particularly understanding such kind of hazards and to
Hmm.
prevent those hazards also. So the group of scientists are working in a different aspects, resilience also, then mitigation also, but there are some engineers, okay,
Hmm.
with which we are collaborating, that also will play major role in the future.
Right. That was really insightful, sir. So, with that, sir, we come to the end of the session. Thank you so much for joining. It was a wonderful session. We got to learn a lot of the insider knowledge about geology, paleosciences, and different kind of like natural ecosystems that exist in our nature, really which was really insightful, sir. Thank you so much. Thank you
Thank
so
you.
much for the
Thank
session.
you, Ankit. Thank you so much.
Okay,
Good,
sir.
good night. Good night. Good night.
Right, sir. Namaskar, sir.
Namaskar. Good night.